Hello, my name is Braden Stump, and I'm the Director of Product and Business Development at Handic Scientific and also its division, Aerosol Devices. And today I'm here to do just a quick tech demo and description of one of our new accessories to our aerosol sampling instrumentation called the TLC, otherwise referred to as the temperature liquid controller. So if you've watched some of the other YouTube videos describing how our aerosol sampling technology works, you have probably seen me discuss that one of the things you will have to note when doing a longer length liquid sample with our technology is that you will have to deal with fluctuations in the liquid level of the sampling vial of our instruments. Notably on the BioSpot Gem and on the spot sampler, this is a much smaller volume, a 300 to 600 microliter liquid vial. So because of this, our team has developed an accessory technology that we call the TLC that allows us to automatically control the volume in a liquid sample over time to deal with those issues. And I'll be showing you it in person and how it works, but just wanted to provide a brief description from this diagram that we have in the user manual to kind of get us started. So a instrument like the spot sampler, typically sampling into a liquid vial, we don't have the ability to dynamically control moderator temperature or temperature of your sampling vial over the course of a sample for, say, 8 hours, unless you're manually modifying it. The problem with that is, as we've discussed plenty of times, you can see a lot of change in liquid level due to particle concentration changing during your sample, and also just the thermodynamic balance between your moderator temperature, so your outcoming total water vapor in the flow based off of the exiting dew point that you're setting with your moderator, as well as the temperature of your sample, because the temperature of that liquid versus the amount of water vapor and what temperature it's coming out is going to affect evaporation or condensation into your liquid vial. So we have designed a system, and I think that I have a larger diagram here. And if you would like a copy of the manual, please feel free to reach out to me. I think that, yeah, this is probably the best diagram, the one above. Here we go. That utilizes a liquid vial cooler here, a cooling sleeve around liquid vials for either the spot sampler or the BioSpot Gem, and then a camera to take pictures of the liquid level inside of a vial for certain amounts of time. And then utilizing that knowledge of how the liquid level has changed over the course of the sample, we are utilizing our kind of main TLC box to communicate back with the spot sampler or BioSpot Gem to change conditions over time to dynamically maintain the liquid level in this file. So folks doing longer 8-hour, 24-hour samples that are looking for this to be a bit easier, there are ways to do so. Still requires a little dialing in, but it is not as, let's say, intense to deal with. The last thing I was going to show before we started, kind of the method and the control loop by which this happens is every 5 minutes. Right, we're going to find this. Every 5 minutes, the TLC is taking a picture of the liquid vial's liquid level. And the pictures end up looking like this. We'll review more of them later. The way that it does it is after 5 minutes of sampling, it stops the pump for a few seconds, takes that picture of the liquid level, uses machine vision to determine, is this higher than or lower than the starting liquid volume picture that I took? And if it is too low, moderator temperature is increased. If it is too high, moderator temperature is decreased. So effectively, there's this direct correlation between what you want to see happen in the vial and your moderator temperature because you're holding your sample temperature static. With that, let's start getting to the fun stuff here. And I have a spot sampler here and a TLC unit that I'll be able to kind of show you how things come together. Just because this is more of a tech overview and less of a direct training, I'm going to take things a little bit faster than usual. So in order for the TLC to mount onto the bottom of a spot sampler or a gem, we have a small, and I will pull the camera on a small mounting bracket here and a liquid vial installed. This mounting bracket mounts to the 2 screws that typically the front of the sequential mounts to on the spot sampler. And all that does is give us a place to mount our TLC cooling sleeve. From there, you will see the spot sampler is also already plugged in with its power cable on the back. And then notably, we have plugged the one end of a data stream cable into the back of the spot sampler here and are plugging the other end into our friend, the TLC. We also have connected into the TLC here just to make it easier to connect to the internet. We also have an Ethernet cable here in the box. I will show that off as well. Power cable, USB cable, Ethernet cable, as well as a power switch right here. So the other thing that you will see is this is a TLC. This is the cooling sleeve unit as well as the camera unit. There is a Raspberry Pi camera embedded right here, and then small lights and a cooling sleeve with a Peltier cooler and fan coming out of this end. And the idea here is to cool the vial to a set temperature that is convenient to modify your moderator temperature around, but also is generally a static temperature to make sure that your changes in moderator work properly, even in different ambient room temperatures. So the way that we install this cooling sleeve and actually start a sample with our TLC. So as you will see here, we've already got a vial installed with liquid in place. So that is ready to go. This spot sampler was recently had its wick wet, recently got down to temperature. So we will get started with that process pretty quickly. It can be a lot faster than usual, which is nice. So we're going to turn our spot sampler on first. Turning your sampler on first is pretty critical in this process. Making sure that it gets temperature, all that. Wick is already wet. I'm going to go ahead and start this sample because we aren't looking for experimental integrity here. We're just kind of looking to show off how things work. And then the next thing that we want to do is put our cooling sleeve on around our vial. So this, and I'll show this again, there are two holes here with prongs and then these little captive screws. You are pushing that up and in, turning it into place, and screwing it in. Perfect. So now that is locked in place, that cooling unit is going to start working. It is absolutely critical when you are running experiments with the TLC that the TLC is actually turned on after, and I'm going to actually turn the box up this way so you guys can see the screen, after the sampler is on, or else it will not connect properly. So I'm going to turn on the TLC box. You'll be able to hear the fan or the TLC here start working. This is currently a embedded, this is a cable that will always be staying in place just so that you're aware that it's not removable of any kind. Later versions might have removable cables, but for now, this is a static cable attached to both the box and the cooler, primarily because of the camera cable coming through here. As this is warming up, perfect. You'll start to see firmware version initializing. If it matters to you, and if you're connected via Ethernet cable here, you will be able to see your IP address, which is useful to potentially take a picture of. And then these units also have a real-time clock now, so you will be able to see when the real-time clock is updated because it is connected to the internet, to its new network time set here. You're seeing Ethernet port, network time set. So now you're seeing options for starting sample, a sample time, a sample temp, and then enter to start. I'll just go through all these menus. I'm going to be doing a 16-hour sample. So if I press the up button, we can look at time set in hours and minutes. You can press the enter button to edit that. I won't be editing that today. I'm just kind of keeping it, brisk, moving it along for a general review of how things work. This is elapsed time. So every 5 minutes when the pump stops, this is not counting down. We're only counting a sample down when the pump is operational. So elapsed time on a 16-hour sample could actually be something more like 16.5 hours, but you're only getting when the pump is sampling, when this is counting down. Sample temp, I have listed as 10C. That is the temperature of around the vial here. General recommendations would be for the BioSpot Gem to start at a 12C sample temp, and for the spot sampler to start at a 10C sample temp. If your ambient environment or your aerosol conditions are causing you to not be able to control liquid vial level, this is a good place to start. based off of how much aerosol concentration you have in the air. In this case, there's not very much aerosol concentration in the air here. And I have low RH in this room, about 17%. So it's easier to have a lower sample temp in order to allow the moderator temperature to kind of adjust around that. And then finally, we have a little bit more of a hidden user setting, which is your starting moderator temperature. This effectively allows you to help with the kind of the control from having it bounce around too much or having too much of a poor start. If you know a good starting moderator temperature that keeps you from fluctuating too much as a good base state, this is a good time to enter that. So we'll go back down though and go ahead and hit enter to start our sample. We have a liquid vial loaded, we're down to temp, and we're ready to go. Great. So now this says sampler warmup complete, enter to sample or up to add delay. If I hit enter right now, that sample will immediately start. However, if you're looking to do some sort of delayed sample where you're arming it to start at a certain time, you can press up here and you can select a UTC time. So the top row is the time that it currently is with the real-time clock. And then the start time is sometime past that in the next 24 hours. It's limited to that because of, water in the liquid bottle. You're wanting to make sure it doesn't run out. You want to make sure your wick stays wet. So this gives you a way to, in the next 24 hours, begin a TLC sample or just generally a liquid spot sample of some type. We're not going to do that now. We're going to hit the escape button, and we're just going to go enter to sampling now. So sample level check is occurring. You can see the air pump to the sampler has now turned on and then off again to just kind of like dose a little bit of water into the liquid vial. And it is now started to begin. So you'll see this change in just a moment. You're going to see sampling on, remaining time 15:59, and then you're going to see moderator temp 18C, sample temp 10C, and you're going to see that timer start to count down. So effectively, this is what happens when you're doing this sample, and we'll look at log files actually while it is operating, because I think those are pretty cool. One moment. So going to turn camera towards me. While this is operating, we actually can utilize tools. This isn't necessarily the primary tool you want to use, but I want to be able to look at pictures quickly here. So when you're entering stuff in, you will be able to communicate via settings that are in the manual. We'll be able to talk about that if you get an instrument and have more intense training. But wanted to be able to show what sort of photographs of vials you're going to see. This is the picture of the vial that we just got. Perfect. So you're seeing here around your conical liquid vial, this is the bottom of the cone of the liquid vial here, and the machine vision is properly sensing where that is. You're also seeing the bottom of the meniscus here of where the liquid level is. This is actually where the nozzle of the liquid sampling unit is. So we're properly sensing the liquid level of our sample right now. And what this will be used as is a baseline where every 5 minutes, if it's seeing a line above this, it'll turn the moderator temperature down. If it's seeing a line below this, it will turn the moderator temperature up. The advantage to utilizing this method is you're not diluting your sample. You're not adding additional liquid. You're just changing the condensate of your sample that comes afterwards, your vapor. And what's nice about that is you're not changing droplet growth in any appreciable way. You still have the same sampling efficiency here. But this allows you just a little bit more flexibility in sampling for longer periods of time and not having it drastically affect your sample. We typically see on samples of this nature a fluctuation of about 25 to 50 microliters in either direction over the course of a full sample. I can also pull some, I'll look and see if I can find any good examples here on my desktop of how TLCs have performed. This is a perfect. This is a 24-hour run. So I can, one moment. You can see sample temp, sample level staying pretty well consistent there. Let's see, I can grab an 18-hour run here. This is another really good example. You are seeing on this meniscus, this is not changing very much, but when it is changing, it's just kind of slight adjustments. I think on this sample, we did get something a little bit more in our log file here. We're seeing, from what it calls, 660 microliters up and down. And I'll go ahead and graph this so you can kind of see what fluctuation looks like here. Great. So what you're seeing here, and I should probably have this better prepared in Excel. This orange line and this axis over here, what you're seeing is the moderator's temperature set point. And then this blue line here is the actual liquid level of your sample. So you're seeing as liquid level is increasing, moderator temperature is adjusting down to bring that liquid level down. Once it gets below a certain threshold, it's increasing to kind of create this sine wave of what we're seeing from about zero point 0.7 milliliters, which would be 700 microliters, down to about 630 microliters. So about a plus or minus 35 microliter swing in this case. So not terrible, not as dialed in as it absolutely could be, but definitely much better than if you were to try to run a sample without this sort of control present. With that, though, what I'm going to do last here is show how we can access log files on the instrument. I'm going to go ahead and press escape to abort our sample. And it makes you ask enter to confirm. It tells you you aborted your sample at a certain time, turns the pump off on the sampler. And then I'm going to go ahead and turn the TLC off, as well as the spot sampler off. In my case, I was wanting to show you guys some files on the instrument while it was operating. However, we do have a new way to pull log files off of the instrument, specifically the TLC it should allow you to quicker access information. So I have a little Handix branded USB flash drive here. And if all that I do, if I plug this directly into the USB port on the box and turn it on and wait a little bit, and as an aside, while we're waiting for this to load, all of this is assuming that your spot sampler is already set up exactly the way you want it. You can use liquids other than water in the liquid vial. We have seen different, reflectivity, and you're seeing beginning file transfer to the USB here. We've seen different reflectivity of different sample types be fine. As this is beginning the file transfer, transfer complete, files moved 574, reconnect sampler, then reboot. Perfect. We now have all of our log files have been deleted off of the TLC and have been placed onto this USB. That is primarily useful because when you start a new sample, it will overwrite over previous samples. So you definitely want to make sure to pull your log files out if you want them off of the TLC before starting a new run. Great, we're seeing that here. Gonna go ahead and turn the TLC on again. Once again, seeing the process of sampler on first, then TLC. As the TLC starts up, it will do a systems check to see whether or not a sampler is connected to it. So it's pretty important to make sure that this is ready to rock first. So the last thing that I'm going to show you before we go ahead and close things out as the TLC turns on is that I'm going to show you about some of the new remote access capabilities of the TLC. I'm going to go ahead and share screen again. Hello, everybody. And I'm going to type in TLC-02.local. So what's happening here is that on our local network, as I'm plugged in with Ethernet right now, and the serial number of this instrument is TLC-02, I am now able to access a very cool web page once it loads. Oh, I think so. I might have something a little bit wrong here. One moment, I'll check the user manual. All of this is happening live, folks. So yeah, you should be able to type into, if you're on the same network as the TLC, type in TLC-number.local, where number is the serial number of your TLC unit. Let's take a peek and see if it works this time. Oh, popped open. Sorry about that. Just got to wait for it to load a little bit. So what you're seeing here is a direct replication of the buttons and the screen of the TLC. So if I interact with the TLC in any way, if I press up here, you're seeing it change here on the screen of the TLC as well as on the computer, as long as you're on the same network as it. Benefits here is that you should be able to, one, control the TLC and be able to, keep an eye and make sure your sample is still running properly here, but also remotely control or remotely start the instrument. So this is all of the exact same settings as before. I can modify things as we see fit. And yeah, as long as you're on the same network and able to locally access this, it should be as easy as going to your browser and typing in TLC-serial number.local. So with that, I think I'm going to turn off both instruments and do a quick little outro. So this was the tech demo of the temperature liquid controller, the TLC from Aerosol Devices, a division of Handix Scientific. Please feel free to reach out to me, Braden Stump at bstump@handixscientific.com if you have any questions, if you want a quote, if you're looking for technical support, if you want to learn more. Our job is to help your all's samples be as successful as possible. And if you have instrumentation that you're looking to extend the liquid samples on, or any other research questions, we would be happy to help. Thank you for your time and have a good day.